We are discussing interference in waves, right, in this particular video. So let us say we have a medium in which a wave is traveling. Let us say these are the particles. Let me show them. Let us say these are the various particles of the medium. And let us say a wave travels in this particular medium along this direction. Right? So what will happen is these particles will start moving up and down, perpendicular to the direction of propagation of the wave. So if this is the mean position of the waves, we will have a wave something like this, which will move further down, right, low. So let us say we have this particular wave going in this particular direction. So if you look at one particular particle, this particle goes to this particular point, right, at some particular time t, right, then it starts going down, again comes back to its mean position and again goes down. This is how the particle will move up and down as the wave propagates. The question that we are discussing in this video is what would happen if instead of one wave which is shown over here, there is one more wave which is also passing in the medium. Right? So let us say there is one more wave, right, which I'll show like this. Let us say this is another wave which also is traveling in the medium. Okay. It goes down like this. So now there are two waves in the medium, meaning that a given particle is affected by two waves. That means there is a force acting on a particle because of two waves. Right? This particular phenomenon of two waves passing through the medium simultaneously is known as superimposition. Right? These two waves are superimposing onto each other. Right? What happens is this particular particle now is affected by two waves, and therefore its displacement changes. Since it is affected by two forces, the net displacement of the particle is the sum of this displacement, right? Because this wave is asking the particle to go up, this wave is asking this particle to go up to here. The net result is it goes much higher. And the net wave, if you can use that term, net wave would look something like this. So the net displacement or net amplitude increases, right? This is the amplitude because of the first wave, this is the amplitude because of the second wave, but then the resultant amplitude, right? This is the resultant amplitude, it increases, right? And since intensity of a wave is proportional to a square, we say the intensity of the wave increases. Right? This is interference of wave or two waves superimposing onto each other. We also use the word these two waves are interfering onto each other. Let us take another case. Right? We may have a situation like this also. Let us again draw the diagram. Let us say these are the particles of the medium. I'll show the mean position. So there are particles on this. These are the particles. Right? These are the various particles. Now one wave could be like this. And the other wave, the second wave, is not the wave I've shown over here, but is something like this. Let me use another. Let us say the second wave is like this. Right? So in this case, what is happening is that there is a crest matching with the trough over here. So if I look at this particular particle, what is happening is this wave tells it to go up, whereas this wave tells it to go down. Right? So the net result is that this particle does not move because these two waves cancel out each other's effect, and therefore the particles remains in this position. And this is what happens with all the particles. And if I show the resultant wave of this in this particular case, we do not have a wave. The wave will get cancelled out, and the net displacement or the net wave will be a straight horizontal line. Right? Straight horizontal line. So in this case, the net wave is this dark black line shown over here, because these two waves are cancelling out the effect of each other. This also is a case of interference of two waves. Now, in this case, these two waves are destroying each other, or they are destroying the effect of each other. Therefore, we call this as destructive interference. Destructive interference. Whereas in this case, the two waves add up the effect of each other. The net resultant is more than the individual displacement or individual amplitude. And therefore, in this case, we call this as constructive interference. Okay, that's what I wanted to do in this video. I wanted you to introduce you to the term constructive and destructive interference. Net resultant amplitude over here is nearly zero, whereas here we have the amplitudes adding up. Right? Last point before I end this video is that we have taken a special case. We have taken the two waves such that they have same frequency. Right? These two waves, the two waves here and the two waves over here that we have taken waves of same frequency. Let me explain that. Right? Let us say we have a wave going in this direction. Let us say we have a wave like this, right? Now, if there is a wave which has got the same frequency, the second wave will also be equally spaced apart, meaning that even if its amplitude changes, still it is equally spaced. So the second wave could be something like this. This has lesser amplitude, but it is equally spaced apart, right? As you can see over here. So these points are being maintained. These distances are being maintained. And we say these two waves have the same frequency. If the two waves did not have the same frequency, we would have a situation like this. For example, the first wave would be like this, for example, right? And the second wave would not be spaced apart and this way. It might be like this. So you can see the second wave is very close to each other, whereas in this first wave, the waves was widely spaced apart. So these two do not have same frequency, whereas here we have same frequency. For ease of our discussion, for sake of simplicity, what we have done is, in this case, we have considered waves of same frequency to help us understand what is constructive and what is destructive interference. Okay. In the next video, we will look at the math aspect of constructive and destructive interference and the conditions under which these two interference occur. Thank you.